This is Honors Algebra 2 Pre-Calculus, and we're doing 9.5 in Pre-Calc, which is the Binomial Theorem. So we're on page 654, and after several videos, we are finally actually getting to the Binomial Theorem. So at the bottom of page 654, you'll see that the expansion of x plus y to the n is given in this, like, lots of letters, totally daunting, but you're going to be fine expression. So x to the n plus n, where n was the power on the original expression, n x to the n minus 1 times y to the first, plus dot dot dot, and then there's that NCR that we talked about in the last video, right? In our last video, we talked about NCR. So n choose r. X to the n minus r, right? Y to the r, and then dot dot dot, and then we eventually get to the point where we have an n times x to the first, and a y to the n minus 1, and a y to the n, okay? So what this allows us to do is this allows us to find much larger expansions past something that would normally be accessible on Pascal's triangle. Now you might be saying, but Hogan, if I had to do that, then will I have to do this NCR thing for really huge numbers? I'm going to walk you through how you can actually make your calculator do that pretty easily. Let's start with talking about how we can make our calculator do NCR. So NCR, right, which we know is the same as this notation with an n over an r in parentheses, and we know it means an n factorial over an n minus r factorial times an r factorial. But in our calculator, the way we get there is if you go to math, right, so you press the math screen, right, and you go over to probability, right, you'll see that the third one down is NCR, right? So if you go to math, right, and you go over to probability, you'll notice that the third thing is NCR. So the way that you put this in your calculator is that you have to put the number first. So as an example, let's just say that I wanted to do, we already did 5, choose 3 in the last example, so let's do 5, choose 3 in our calculator. The way I type this in my calculator is I pick the 5, I get the NCR using these steps in my calculator and the 3, and then I hit enter. So let's go ahead and walk through doing that, right? So I would do 5, right? I'd go to math, over to probability, and I'd pick 3, and then I'd put the number 3 because I want 5, choose 3, and I'd hit enter, and it would give me a 10, okay? So that's how you have to put it in your calculator. So if you were asked to find a really big power, like if you were asked to do like 200 choose 57, that would be awful by hand. But you could do 200 choose 57 on your calculator. You might not actually be able to. That might actually cause what we call an overflow. Sometimes your calculator asks you to do stuff that's too big. But that's kind of the gist. So what we're going to do now is let's actually see if we can find a particular term in an expansion. So this would be our example 5, maybe? I don't know, I'm really bad at counting. So I think this is example 5. There's a chance it's 4, but we'll just deal with it. If it's 5, so on. So be it. Or if it's 4, so be it. Okay, so let's say I asked you to do a bigger power. Let's say I asked you to do x plus y to the 20th, which is not super fun, okay? So what if I don't ask you for the full expansion? I ask you to find the coefficient of the x to the, let's do 17th y to the 3rd term. Now what I want you to notice is that these two powers do sum to that 20, and you can see that in any of the previous examples that we've done. Now there are sometimes some weird cases where that's not true, like if this had been an x squared inside the 20, then that would mess things up, but we can do some examples like that later. So I want to find the coefficient of the x to the 17th y to the 3rd term. Okay, so let's compare. So I don't want to write the whole expansion out because that sounds just generally horrible. So let's give myself some space here, and we're going to walk through how we could do this. So what we're talking about here is we are looking at this thing right here and saying, well, what term am I talking about if x is to the 17th and y is to the 3rd, right? So what I want you to notice is if we compare this, we're trying to find some mystery coefficient, right, of x to the 17th, y to the 3rd. Well, notice that in each term, the power of y is r, right? R is the power of y, right? And x is to the n minus r, meaning, and we already know that n is 20 because this is an x, right? This is x plus y to the n, right, to the 20th. So we know n is 20, and we know r is 3. So what that means is the coefficient I need is 20, choose 3. That's the coefficient I want to find. So in order to find the coefficient of the x to the 17th, y to the 3rd term, I need to do 20, choose 3. So I can do that by hand if I want, or I can make my calculator do it, right? So to do 20, choose 3, I'm going to do 20, right, math over to probability, pick 3, and I'm going to do 20, choose 3, and hit enter, and I'm going to get 1,140, which I didn't feel like doing by hand. So I'm going to get that the answer is, the coefficient is 20, choose 3, which would be 1,140, right? So if you wanted to see that whole term, that entire term would be 1140 x to the 17th y to the 3rd. So again, what the binomial theorem lets us do is it lets us pick a particular row in Pascal's triangle, right? Lets us pick a particular row in Pascal's triangle, or it lets us pick a particular term in that row, which is useful because I didn't want to make 20 rows of Pascal's triangle. That's not a good use of anybody's time. If you're only expanding something to like any power between probably 2nd and 5th, I would advocate using Pascal's triangle. But if you're asked to do a higher power, it just doesn't really make sense to do the triangle. It makes your life kind of awful.